if M is a finite set of negative integers, is the total number of integers in M an odd number? And then I can glance at my statements here and see they are both talking about the product of all my integers in M. So let's think about for a second. Say I have 3 numbers in my set. So it's going to be 3 negative numbers. And so when I multiply these together, a negative times a negative will be a positive, but then I have this extra negative remaining. So I'll have a positive times a negative, and the whole thing will be negative. Let's say I had 4 terms in my set. Well, in this case, both of these are flipped to positive, so I really just have both my pairs, I should say, have a positive product, and so I just end up with a positive times a positive. So the whole thing is positive, and so this is always going to be true. So when I have an even number of terms, I'm always going to have a positive product. When I have an odd number of terms, I will always have a negative product. And so if you glance in the statements, then once you do that, you can sort of rephrase this question as, do I have an odd or even number of terms in my set? I say let's just look at the statements. So the product of all the integers in M is odd. Okay, so what does that mean? That just means all of the values in my for the terms of my set must be odd. So I just have an odd, but I can have an odd. So I can have, so here there's not a 0. This is an O for odd. So I can have 3 odd terms though, or I can have 4 odd terms. So this doesn't help at all. Because remember, so anytime I add an even, the whole thing will automatically become even. So the only way to get an odd product is you got to have all odd terms. So this is odd number of terms, even number of terms. So they're trying to confuse you, it seems like, by conflating the even or oddness for the values of your terms for the even or oddness of the number of terms. They're not really related at all. Statement 2 says the product of all the integers in M is negative. So this is not what we're talking about here. So this means if the product is negative, we must have an odd number of terms, which answers our question. So I forgot to say, statement 1 is insufficient. Statement 2 is sufficient. And B is the answer.